Hello everyone. Today in this video we'll be discussing the CG lab programs 1 to 4, the technique to memorize it and what are the patterns you can find in it, and those things we'll be discussing. So watch the video till the end, and if you like this video hit the like button and don't forget to subscribe to my channel. Okay, so what are the first 4 programs that I have considered? The first program is the Line Bresenahm algorithm. Second program is the triangle rotation, and the third program and the fourth program is cube rotation and cube camera. Okay, these are the 4 programs which I have considered. Now let's see what are the tricks which are present in these 4 programs, the patterns which we can find out. So each of these programs have 2 parts. Okay, first is the header file section and second is the void main function, and in between the void main function, that all includes the global variables, the user defined functions, as well as the int main function. Header files are these 3 header files you need to keep in mind. Hash include stdio.h, math.h, also stdlib. I forgot to mention stdlib also. Okay, stdlib.h as well as gl/glad.h. Okay, these are the header files which you have to include in the first part of all the programs. Okay, then comes the global variables. Okay, in every program we have some global variables which are declared at the top that we have to keep in mind. In Line Bresenham's algorithm, what is the main aim? Okay, Line Bresenham means what? We are drawing the line between 2 points, right? So each point will be written as x1 y1. Okay, this is x1 y1 and this is x2 y2, right? So these are the points which will be taking as global variables. So 4 global variables will be there, x1 y1 and x2 y2. Written the header files, we have written the global variables. After that comes the functions part. So there are 5 functions here which are user defined. So 1 2 3 4 5. After that we have the int main. This is the whole program. Header files, global variables, 5 functions, int main. Header files, global variables, 5 functions, and int main. Now let's see what is there in the 5 functions. In the 5 functions, before that, use gl int and gl float instead of int and float in every part of the program. Okay, so all you need to keep in mind is just are we using the float value or the int value, because obviously you will not write int. Even if you write int, you will get in mind that you write gl int, so you'll write there gl int after writing int, right? So don't worry about gl int and all, just focus on what is being happened in the program. Okay, so the 5 functions are display, init, set pixel, Line Bresenham's L1 which is less than 1, and Line Bresenham which is greater than or equal to 1. After that we have the int main. Okay, so let's discuss what is there in these programs. So in the display function, if we come, you have 3 things: m, 2 lines, if else. M means what? Slope, right? You are trying to find out slope, and that is equal to y2 minus y1 divided by x2 minus x1. That's what we are trying to do here. We are finding out the slope. So we'll take gl float m is equal to y2 minus y1 by x2 minus x1. We'll use math.apps also. And after we have got that, we'll be drawing 2 lines. Which are the 2 lines? The vertical line and horizontal line. Remember the vertices, minus 500 to 500, and here also minus 500 to 500. So write it accordingly, like it is 0 comma 500, and this is 0 comma minus 500, minus 500 comma 0, and 500 comma 0. Okay, these are the points in between we are drawing the lines. In between we are changing the color as well. We'll be discussing now what is that. And finally we have the if else condition, means if the slope is greater than 1, at that time we'll call Line Bresenham greater than or equal to 1, that bottom part. Else if it is less than 1, the slope is less than 1, we'll call this function. That's all what happens in the display function. If I show you the display function, we have the display function here. Okay, from the starting, these 3 header files you included, the global variables you have written, and these are the 5 functions, and we are currently in the display function. So see what is there in the display function. What I talked about, the main part of the program is gl float m we are calculating. We are drawing 2 lines. This is vertical line. So the points are minus 0 comma 500, this point till 0 comma 500, this point, and horizontal line, which is this is gl begin gl end. Between that we are marking 2 points. Minus 500 comma 0 is this point, and 500 comma 0 is this point. So 2 lines are being made, and we are just changing the color before the drawing of the lines. This will change the color to green, and this will change the color to red, because it is RGB, right? RGB means R is 1, G and B is 0, so it will be red. Here it is green because G is 1 and the rest 2 is 0. So first it will draw a red line like this, and it will draw a green line like this. Okay, so this is how the output will look like. Okay, so that's what we are doing here. The main thing, drawing the lines, calculating the m value, which is the slope value, and after we have calculated, we are using if else condition to check either we have to call the slope which is greater than 1 or less than 1. And obviously if you are trying to call these two algorithms, what we are going to pass is x1 y1, x2 y2 and m. Here also the same thing. So this is clear. Okay, display function is clear to us. Now let's move to the next part. What is there? The display function. And in init function there are 6 initializations. Okay, so what do I mean by 6 initialization is there are 6 initialization functions which you have to write. So let's come to init. In the init what you have is C. GL clear color 1 comma 1 comma 1. What is 1 1 1? That is RGB is 1 means it will show white. So we are setting the white color here. GL color 0 0 0. This is for the pen color we are setting. The marker color it is set to black, and the size is being set. The width is set as 3. And after that we have the matrix mode, which mode we are trying to project it. Projection mode. Load identity, the identity will be loaded, and ortho 2D between minus 500 500 and minus 500 500, which means this one to this one. Okay, it will be loaded. So yeah, that's all. This is the 6 initializations you are doing. So you can memorize this by writing 3-4 times. Okay, that's all what is the init function. So till now what we have discussed is there is header files, global variables, and after that we have the display function, and we are doing the init function now. Okay, so let's move to the sheet. So now sheet, what is the next thing is, after the init function is the set pixels function. Set pixels basically just points a pixel in the graph, just that one. Okay, just what GL begin, write the vertex, the points will be passed in the arguments, use the same points. Vertex, this point should be marked here. GL end, begin, end, mark a point in between that. That's all what happens. If you observe carefully in the set pixel code, what we have is GL begin, GL points, GL vertex to x coordinate, y coordinate, this passed here. You can take it as xy also and write it here xy. GL end, that's all. The point is marked, and GL flash if you want to write, else you can also skip it. Just for the refreshing the buffer. Okay, so that's all what is happening. Set pixel, whatever you pass here, that pixel will be pointed here. Okay, so header files is discussed, global variables, display function, init function, and set pixel function. Okay, so after learning every new function, we'll be revising the previous one so that it stays in our mind. Okay, let's move to the next part. We are means we are left with two functions, which is Line Bresenahm less than 1 and greater than or equal to 1, right? So in less than 1 what we have, see what is less than 1. Less than 1 means it is going like this. That means x is incrementing faster than y. So x plus plus you have to do in each iteration. This is the basic thing you need to know. Okay, and what is in the arguments? In arguments we have x1 y1, x2 y2, as well as m. So int we'll take gl int 4 times, write gl int gl int gl int gl int, and here we have gl float for the m value. So that are the arguments which are passed. You can easily write that. Okay, and x is incrementing faster. So these are the official things which you have to take. Dx, dy. Dx means what? X2 minus x1. Dy means what? Y2 minus y1, right? And p you have to take the initial value of p. Keep these things in mind. Dx, dy, p is equal to 2 dy minus dx, and 2 dy you will be taking as 2 into dy, 2 dy minus dx, 2 into dy minus dx in the brackets, and x and y initial points. Initial points you will mark x and y. See, x and y are the points which you will be marking. Every time they will be changing. Okay, so the first points are x0 and y0, which you pass in the arguments. That will be marked as x and y values. And if it is the x is greater than x end, you will mark it as this one, else you will take the initial points. Okay, so this is just the initialization points. Let me show you this part in the code. So in the code it looks like as follows. This is the less than 1 function, and here we have x0 y0, which is x1 y1, x and y end is x2 y2, and here we have the float value. Dx we are taking, dy we are taking, p is equal to 2 dy minus dx, 2 dy is taken as 2 dy, 2 dy minus dx. After that we have gl int x and y is initialized as x0 y0, which is the initial points. Now we are seeing if the points are greater than the x end value or not. If x0 is greater than x end, take xy value as the last values, x end and y end. Okay, else take the initial values only and set the pixel. After you've taken the first point, set that pixel. Okay, that's all what is as of now what we have reached this much. Okay, and after that what we are doing, this is the main part, while loop. In while loop what we are trying to do is we are trying to see if we have to increment the y value or not. Y plus plus should happen, or it should stay y only. That depends on p value. P is the deciding factor. So x will increment anyway, x plus plus, if p is less than 0, if p is greater than 0. If p is less than 0, keep y same. If p is greater than 0, I increment y. Only if p is greater than 0. Only if p's value is greater than 0, increment y, else keep y as same. Don't do anything to y. And change p value also as follows. Plus is equal to 2 dy and plus is equal to 2 dy minus dx. That's all what is there in the while loop. If we discuss in the code part, in the code part it's written as follows. X plus plus you will do first. If p is less than 0, then what you will do, p plus is equal to 2 dy, y will be same, so you will not do anything. And else m is less than 0, y minus minus, else y plus plus. Okay, you can just directly write y plus plus. Okay, it does not make much difference. And p plus is equal to 2 dy minus dx. Just remember the p values. So in the main function, which is the line Bresenahm function, what you have to take, dx, dy, p, and 2 dy, 2 dy minus dx, and initial values of x and y, is it x end, y end, or x naught, y naught. After that, set the pixel and find out p value. If it is less than 0, plus is equal to 2 dy. Okay, and y will keep y will be same. Else what you have to do, p plus is equal to 2 dy minus dx and y plus plus, and x will be plus plus as every time in this function. Okay, same thing you have to do for the next also, greater than function. Just that wherever you saw x there, write it as y, and wherever you saw y there, write it as x here. That's the only difference. Okay, just the literal only that difference is there in between the two programs. Okay, so that's all what is there in the first program. Let's quickly revise what is there in the first program. Write the header files, stdio, math, and gl glut, and the global variables. Since it is the line Bresenahm function, we need 4 global variables, which is x1, y1, x2, y2. And the function, there are 5 functions, the display, init, set pixel, and line Bresenahm 2 parts. In display function, we are doing 2 things: drawing the vertical line, horizontal line, calculating the m value, and passing the function to either less than 1 or greater than 1. Then in init, we are doing these things: setting the background color, setting the pen color, pen width we are setting, and after that we are setting projection mode, which is GL projection, load identity, and one more function was there. Okay, those are the 6 initialization functions. Then we have set pixel, just basically the setting point function you have to write. Line Bresenahm, do these things: dx, dy, p, 2 dy, 2 dx, xy, is it the first part or the ending point. Set pixel, then while loop, while in the while loop, first write x plus plus, then if p is less than 0, p plus is equal to 2 dy, else p plus is equal to 2 dy minus dx, also y plus plus. Same thing goes for the greater than 1 also, just the values will differ. Wherever you find x, replace it with y. Okay, that's what there is in the first program. And let's move on to the second one. In the second one, what we have is the triangle rotation. Okay, so in triangle rotation, the same things. First you have to include header file, then we have some global variables, some user defined functions, and the int main. So global variables are these variables: t, triangle values, rotation triangle values, resultant triangle values, xr yr is the fixed point, xr comma yr, and th is the theta value, and ch is the choice. So why we have used these things, which we'll be discussing now. These 3 things, these come together, these 2 come together, and this one is separate. This what we have is, will be asked with one question when we run this program. In that, what will be asked is, enter the angle, so that will be stored in theta. So for that we have taken th, and enter the choice. Choice means either rotate with respect to origin or with respect to fixed point. Those are the 2 questions which will be asked. Okay, so our choice will be stored in ch. That's why written as ch. Okay, t is the triangle values, initial triangle values, rotated triangle vertices, and the resultant triangle vertices. Okay, so we will be seeing why we are using these values here. Okay, so these are the global variables which I have used, and functions are, there are total 7 functions. Okay, so which are those 7 functions? Let's see. One is the multiply function for multiplying 2 matrices. That function is defined here using 3 for loops. And rotate about, for origin 1 function is there, for fixed point 1 function is there. Just a slight difference, only 1 line difference is there between these 2. Okay, fully same. Same thing goes for draw triangle also, only 1 line difference is there. Here we'll use T matrix. In the rotate triangle we'll use resultant matrix. Else all it is same, rest all it is same. Okay, display, just we are seeing if it is ch is 1 or 2. If it is 1, then go for this one. If it is 2, then instead of rotate with respect to origin, we'll be using with rotate with respect to fixed point. 2 is for fixed point, 1 is for origin. The this function we will be calling the rotate functions, which are either these 2. this one or this one based on the choice. This is for choice 1, this is for choice 2. And my init function for initialization are there, just as how we discussed in the previous program. Like it will set the color, background color, pen thickness and the pen color, and it will set the size and glue ortho 2D from which point to which point it should display, and then name will be set. Okay. And inpin also does the same thing, take ch and angle value, and 6 initialization things are there. Forgot to discuss the intmin of this part. In intmin of this one, we'll have the function to read the values, scanf, printf, the 2 points, and call the function. Okay, that's what happens in the intmin along with the initialization things. Okay, so let's get started. Firstly, I'll show you the program. This is the program. Okay, so here what we have is the header files first, stdio, math.h, and glglut. And here we have the 3 arrays which are related to each other: T array, triangle array, rotated triangle array, and resultant array. And these things you have to memorize. Along with that, we have the XR by R, 1020 it's taken, TH and CH. Okay, and after that we have the void multiply. So in void multiply, what's happening is, by keeping this code snippet in mind, you can easily write the multiply function: I3 J9 K3 393 I J K 3, then J9, then K3. Okay, keep this in mind. I goes from 0 to 3, J goes from 0 to 9, K goes from 0 to 3. Okay, and after you have written I is equal to 3, I goes to 3, J goes to 9, and K goes to 3, then before that write R of ij is equal to 0. That's all. 3 things you write. Before that you write R of ij is equal to 0, and after all what you have to write is at last R of ij is equal to R of ij plus RTIK into T of Kj, Ik Kj, Ik Kj, RT of Ik into T of Kj. That's all what you have to write. Okay, this is the code. If you remember this much, the code part will be very simple for you. See, in the code part also it's the same thing. I is running from 0 to 3. Then we have the for loop for j, it's running from 0 to 9. Result of ij is equal to 0. K goes from 0 to 3. Resultant of ij is equal to resultant of ij plus RT of Ik plus into T of K into j. Okay, that's all what is there in the multiply function. So the first function is over. Let's move on. You have the second function, which is either it's rotate about origin, rotate about fixed point. Now remember, if it is origin means what? It is 0 comma 0. If it is fixed point, we have to take m and n values. Remember this formula, m and n values, xr 1 minus cos theta plus yr sin theta. This is compulsory for you to remember this formula. Okay, xr 1 minus cos theta plus yr sin theta, the same thing. Right, cos theta 1 minus cos theta and sin theta here, just exchange these two. So xr will come here and yr will come here. Just make this plus as minus. That will be the n value. After you've written that, just remember this one: cos theta minus sin theta m, sin theta cos theta n, 0 0 1. This is there in the theory part as well, right? This formula for the rotation triangle, right? For the rotation of the points, we have this formula, right? So that's what you have to remember, these two things. Okay. After you have remembered these two things, the code is pretty simple for you. Both the codes you can memorize very easily. Both the origin rotation as well as the fixed rotation. If you observe carefully, it's just the same thing. GL float mn, we are calculating m and n values, and here we have some code, right? Same thing goes here also for the fixed point, m and n, the same formula, and here also the same code. Just only the difference what's happening here is, here if you observe carefully, cos theta minus sin theta 0, sin theta cos theta 0, 0 and 0 comes after sin and cos theta, right? But here, since it's the fixed point, you have to take m and n value. That's all the difference. Everything is same. Okay, so very easily you got to know the code. Here why I told to remember this formula is because we have to calculate m is equal to xr into 1 minus cos theta plus yr sin theta. N is yr will come here, 1 minus cos theta minus xr sin theta. Okay, that's for mr and m and n values, and we have the cos theta minus sin theta and m, sin theta cos theta and m, 0 0 1. M is not here, but in the next part it is there, so you have to remember that. For that I told remember that cos theta minus sin theta and 0 and m, and sin theta cos theta and n, 0 0 1. Okay, that's all. To write this one you are remembering that. Okay, so yeah, that's all. What is the next two functions, rotation about the origin and rotation about the fixed point. That's all the difference is. Same thing goes for here as well. For the triangle and rotated triangle, the formulas are this one. Just you have to remember, you have to point 3 points. Okay, you have to mark 3 points. GL begin line, GL end. In between that, mark 3 vertex values. For the first one, which is draw the triangle, use t value because that's the initial triangle array, and for the next one, which is draw rotated triangle, use resultant one, initial, final. Just change the name here, rest of these things are same. Right here zeros and ones, then 0 1 2 0 1 2, zeros ones 0 1 2 0 1 2. That's all what you have to write. If I show you the code, that's all what is written in the dot triangle and draw rotated triangle function. Okay, so in the draw triangle function, you can observe we are drawing a line, we are beginning it, we are ending it. In between that, what we are writing, we are changing color. That's your wish. If you want to change, else you can skip because that's not the main part of the program. Here what we have, t of 0 0, t of 0 1, t of 0 2. So 0 0 0 and t of 1 1 1 and 0 1 2 0 1 2. Okay, that's all what you have to write. And the same thing here also, we are means making a line here, and color is getting changed. In between begin and end, we are marking vertex values 0 0 0 1 1 1 0 1 2 0 1 2, and instead of t we have result. That's all what is there in the triangle rotation of rotated triangle or the normal triangle. Okay, that function. Okay, this is what is there in this one. Okay, so we are done with 4, we are left with 2 more. So sorry, we are done with 5 and just left with 2 more, which is display function and my init function. Here 4 initialization are there, very simple. Let's discuss that one. So just as same as the other functions, here also we have the same thing, like in the init function, the initialization things. What I mean is this one, setting the color, matrix mode, load identity, ortho 2D. Easily you can remember by writing 3-4 times. Then the remaining one is the display function. See what we have, this is the initialization thing we have to write, and 2 things are there. If ch is 1, if ch is 2. If ch is 1, draw triangle, draw rotated triangle. First draw the normal triangle, then draw the rotated triangle. And since it's the choice 1, rotate about origin. Here also same thing, draw triangle, draw rotated triangle. Since it's choice 2, call this function which is rotate about fixed point. That's only the difference in the display function. Coming to the last one, which is the int main. What we are doing, printing this value, whether you want to rotate about origin or the fixed point. Then enter the choice here, enter the rotation angle here, and pass that. This is the initialization function, display mode, window size, create window, window position, and glut display function display. Okay, then we have here init and main loop. Okay, that's all what is there in the second program. To quickly wrap up, what all things we need to keep in mind. So let's go to that sheet. So for the second program, what are the things you need to keep in mind is, first you have to start from what, header files. Write these 3 header files. Global variables, these 3 are related, t, rt and res. xr, yr is the fixed point, th is the theta value, ch is the choice. Initialize these values here. Then total 7 functions are there. Multiply functions, i3 j9 k3 393 I j k. Okay, after writing that, before k what you have to write, r of ij is 0. After k what you have to write, r of ij is equal to r of ij plus rt of ik plus into t of kj. Okay, rt of ik into t of kj plus r of ij is equal to r of ij. Okay, that is the first multiply function. Second, rotate about origin or fixed point. Origin means 0 0. Here it means mn. M is xr 1 minus cos theta plus yr sin theta. Cross multiply, yr will come here, xr will come here, 1 minus cos theta and sin theta is here, plus will change to minus. After you have done that, remember this one, cos theta minus sin theta m, sin theta cos theta n, and 0 0 1. Apply the same things in the formula as well. For both of the program, just the difference will come here. For m and n values, make it as 0 for origin, and for fixed point, keep it as m and n. Okay. Then we have draw triangle, 2 types, triangle or rotated triangle. For a triangle it is T, for the rotated it is RES, and here we have the begin line and end line. In between that, just change the matrix name, and these 3 things will be same, 0 0 0, 1 1 1, 0 1 2 0 1 2. Display function, 2 choices, 1 or 2. If it is 1 or 2, both of the cases, draw triangle, draw rotated triangle, and in between you will change if it is the normal triangle or rotate rotate with respect to origin for the first one, and for the second one it is rotate with respect to the fixed point. That function you have to call. My init function for initializations, same goes for inmain, take ch and angle, choice and angle, save it and call 6 initialization functions, and that marks the end of the second program. Okay. Let's move to the third and the fourth program. Those are similar, cube rotation and cube camera. Okay. So in cube rotation, cube camera, what all the things you need to remember? First, the header files, stdio, gl, glut and math.h. Okay. And after that, the global vertices. So what are the global variables here? As in the every function we discuss the global variables. Here, what are the global variables? Vertices, colors, theta, axis. And in the fourth program, along with this, add viewer as well. Okay, because it's about the camera, so viewer will obviously be there. Remember in that way. Okay, like a story. And here we have the vertices matrix, colors matrix, th and axis. So forget about these two. The mainly we are concerned about vertices and color. So and functions, what we have, 6 functions are there along with one another in the fourth program. Actually it's not one extra, one will be removed from the first one and added to the replace in place of that. Okay, means 6 only is there, just one function is replaced here, like spin cube is replaced with keys in the fourth program. Okay, we'll be discussing that. So where we reached, third and fourth program, add the header files here. After you have added the header files, global variables, vertices, colors, th and axis, and here we have the viewer and extra function, and here we have the functions, total 6 functions. Okay, so these things you need to remember how to write the vertices value. If I show you the vertices value, see, along with the vertices value you have another thing also, the cube values. See, these things are there, right? -1 and 1 values here, that's for the vertices. For colors also you have zeros and ones. These things you need to remember exactly as it is, because if any one of the value is deferred, the cube will not be shown as it is expected to be shown. Okay, this is one thing, values you have to remember. And the second values which you have to remember is this one. Same goes for the fourth program as well. In the fourth program also you have the same thing, but the values are slightly differed here and here. So what I will be doing is I will be telling you a trick how to remember these values in the next part of the video. Okay, before going to the trick, let me tell you what is there overall. So how many functions we have? We have total 6 functions, right? So after initializing the global variables, this one, and the theta values here 0 0 0 0 0 0, axis is 1 here, axis is 2 here, and viewer value is 0 0 5. Easily, I hope so you remember now itself by hearing it. And now we are coming to the functions. The function is polygon here and the quad here. Same functions, just you have to write color A vertices A, color B vertices B, and C and D. For the 4 points you have to write here also the exactly same function. If you see in the functions also, if I show you, it's the exact same function, just the name is differed. See here, polygon, color A vertices A, color vertices, color vertices, color vertices. If I show you the next program, here also it is named as quad, but here also the same thing, polygon, color vertices, color vertices, color vertices, and color vertices. Okay, so the first thing is done. The polygon and the quad function is same, you can easily remember and write it, right? That is done. And this I will be telling you how to remember color cube. And this is the third one, display. In display we are just setting th values 0 1 2, so it is 0th location, first location, second location according to the array indices 0 1 2. So th of 0, th of 1, th of 2. That's what mainly you do in the display function. Along with that you do some initialization functions. Same thing right here as well, but add this line of code, which is viewer 0, viewer 1, viewer 2, and then 4 zeros, then another 1 and another 0. Okay, so what I am trying to tell is, if I show you the code, in the code for the display function, see, this is the display function, this is the initialization part. After that we have the rotate f, th 0 1 2, 1 0 0 0 1 0, and 0 0 1. Then we are calling color cube, and this is the initialization functions. Okay, so mainly this thing is happening in the third program. In the fourth program, if you see the display function, what we have is this one, just this yellow highlighted thing is added, the rest all is same, right? Just this line is added, viewer 0, viewer 1, viewer 2, 0 0 0 0 1 0. Okay, if you remember that, you can easily add the display function. So our third function, I guess, that's done. This is a display function. Okay, next what we have is the mouse function in both. So mouse, what you have to remember is just this one, left down 0, mid down 1, right down 2. So left, mid and right, left, mid and right, left, mid and right, 0 1 2, then down 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 you have to write. This thing if you remember, you can easily write the mouse function as well. Same function mouse is there in both the programs. If I show you here, you can easily observe it's the same thing which is there in both the programs. Mouse, left button and down, then 0, middle button down 1, right button down 2, right? And in the fourth program, okay, in the fourth program what we have is the same thing, left button down 0, middle button down 1, right button down and 2. Along with that, in the fourth program we have theta axis plus is equal to 2, and theta axis, if it is greater than 360, subtract 360. Two things, add 2 to theta axis, When it crosses 360, subtract 360. That thing is not present in the mouse function here. Okay, but for the remembering purpose, assume that it's written here only. Okay, afterwards you delete from your mind, but for now keep in mind that it's written. Okay, I'll tell you when to delete. See here, assume that this function is also a part of this one mouse function. First write it like this, then you will make change, then you have to make change. Okay. So after you have written this, plus is equal to 2, and here we will write plus is equal to 1 instead of 2. If it is greater than or equal to 360, then subtract 360. The same thing after you have written for the mouse, both functions same you assumed, then make a change. Write the next function, which is only the change happens here. I told you, right, one function changes, that is this function, spin cube and keys. Rest all is same, my reshape, then last is int. Okay, to quickly wrap up where we have reached. We have reached from here. The header files are here, initialized, global variables, vertices, colors, theta axis, and viewer in the fourth program. Total 6 functions are there, one is deferred. Okay, then we have to set the vertices and colors values. I'll be telling how to set that, and color cube values also we have to set. I'll tell you that as well. And here we have the theta values 0 0 0, axis is 1 in the third program, in the fourth program axis is equal to 2, theta is 0 0 0 in both cases. Here we have viewer 0 0 5. After I said that, polygon and quad is same, color A vertices A, color B vertices B, color C vertices C, and color D vertices D. Same thing here and here. Color cube is this, I'll discuss that in a few moments. And coming to display function, th012 100 010 1001, here also the same thing, but you have to add this line, viewer 0, viewer 1, viewer 2, and 4 zeros, then 1 0. Then in the mouse function you have the same things, left down 0, right mid down 1, and right down 2. Here also the same thing, along with that theta plus is equal to 2, theta plus is equal to 1. If it crosses 360 minus 360, that also you'll write here. Now the only change happens here, we'll come to this change later. Let's see what is the same functions. My reshape is the same function. In my reshape, the normal function are there, initialization function like these ones, nothing else. Same thing here also, just the initialization functions. It is acting as init function here, like my reshape. Okay, and the only thing which you have to add is this one. Okay, remember this, minus 2 2 minus 2 h by w. Okay, see there is a pattern here, minus 2 2. Okay, and minus 2 h by w, then minus will become plus here, plus 2 h by w, 2 is here, 2 is here, minus 2 will become 20. Same thing here also, just instead of h by w write w by h, h by w, w by h, rest all things are same. To recap, write minus 2 2 minus 2 h by w, 2 h by w, 2 and 20, minus 2 2 minus 2 w by h, 2 w by h, 2 and 20. Easily you can remember this. I'll tell you where to how to convert this into code. Okay, let's see my reshape function. In the my reshape function, what we have is, this is the my reshape function. Okay, here just the initialization parts in the third program. You don't have a much code to write in the third program, but in fourth program what we have is the discussing about reshape function. Here the same thing, initialization things are there, and along with that we have this one, minus 2 2 minus 2 into h by w, and 2 into h by w, and 2 and 20. Same thing goes here as well, minus 2 and minus 2 2 and minus 2 w by h, 2 w by h, 2 and 20, and the same thing goes here. Just the h by w is becoming w by h here. Okay, that depends on this condition. We'll come to that later. First understand the code here. Okay, that's the code along with the initialization function, write in my reshape, this one in the fourth program. Okay, now what we have is the main function. In the main function, let's quickly discuss what is there, then we'll come to what is the deferred function in both. Okay, that's what we had left here. Main function is the init function, nothing much. If I just show you the code, just the slight differences are there. Write 3 to 4 times, you'll get to know what it is. Just the initialization functions, and we are calling spin cube here. In the fourth program, we'll call the cube camera function, right? Cube view, color cube viewer, and these functions we are calling. Just the initialization functions we are written here. Now comes the main part, which is the deferred function. I told you, right, this is a function which is deferred. So in deferred function, what we have is this is the, in spin cube we have this one, just this line of code, just copy paste this. It's not in the third program. In mouse this is not there. Okay, that assumption you have made, right? Just write it here in spin cube. That's all what is there. And in the keys, what you have is, if you press small key, small x greater x, small y greater y, small z greater z. For that, x is 0, y is 1, and z is 2. If it is small x minus 1, if it is bigger x plus 1, small y minus 1, greater y plus 1, small z minus 1, and capital Z plus 1. That's all what you have to write in the keys part, and in the spin cube you have to write this. I'll show you both of these functions in the code part, how it looks. Okay, in the code part it looks like this. Spin cube, just this one, plus equal to 1, theta axis plus equal to 1, if it is greater than 360 minus 360. Okay, this is the initialization function. And then we have the last one, which is the here also we had the keys function. See, small x, if key is small x, 0 0 means for x it is 0, and if it is small x minus 1, and if it is greater x plus 1. Same thing goes for y and z, 1 1 2 2, minus 1 plus 1, minus 1 plus 1. And yeah, that's all what is the difference. And let's see the trick part. Okay, in the third and the fourth program of the computer graphics lab, we have the programs which is color cube and cube rotation and cube camera, right? So in that what we have is, see, these things we have in that program. The first is we need to define the vertices. For that we have an array. In that 8 values are given, means 3 values, ones and zeros. Okay, and I guess minus 1 also. So those combinations are given there. And here we have the colors array also, that is also given here. 8 numbers are there for both the programs. Also, while coming down, we have the polygon function in color cube function in the program 3 and 4 as well. There also we have 6 lines of code. In the 6 lines of code we have 4 numbers. Okay, so this is present in the other program as well. So how to remember these programs? There is a trick. Okay, so that's what I'm going to discuss in this part. So starting from the color cube. Okay, so there are how many lines? 6 lines are there. You have to write 6 lines of code. That number should be exactly same, otherwise the cube will not appear as it is supposed to appear. Okay, so how will we write these lines of code? So for the third program, I'm doing for the third program first, then I'll move to the fourth program. Okay, so for the third program, what you have to write is start with like this: 3 2 1 0, then 7 6 5 4. Simple, right? 3 2 1 0 7 6 5 4. After you have written this one, start from here: 2 3 7 6. Okay, write it like this: 2 3 7 and 6. Then after that we have, in the same way like how you did through 2 3 7 6, right? Do 4 5 1 0. Okay, so right here 4 5 1 0. Okay, after I've written 4 5 1 0, then come to this part here: 2 6 5 1. Okay, 2 6 5 1, and then 0 4 7 3, 0 4 7 3. That's how you write the color cube function for the program 3. Okay, these are the numbers, the sequence you have to remember. I'll show you the program how it looks like, means where you have to write this, but this is how you remember. To quickly wrap up what we did here: 3 2 1 0 7 6 5 4. Easily you can remember, right? And then start from here: 2 3 7 6, write here 2 3 7 6. Then start from here: 4 5 1 0, write 4 5 1 0. After that take the middle part: 2 6 5 1, write 2 6 5 1, and start from here: 0 4 7 3, 0 4 7 3. That's for the third program. For the fourth program, you have to modify this slightly. Okay, so we have written the color cube code for the third program. Same thing we'll be doing for the fourth program as well. So the first step is how to convert this one to the fourth program's color cube is, we'll be writing it as A, B, C, D, E and F. Those denote these lines. A denotes this line, B denotes this line, and so on. After you have written this one, observe carefully, I'm just writing A as such here. Okay, same as I'm writing just A here. Okay, after I've written A here, then what I will do, I'll write B here like this. Observe this pattern: A, B, then again C, D. Okay, then it should be E and F, right? Because A, B, then C, D, E, F, but write it F, E. Okay, this step if you remember it, the rest of the code is very simple for you. After you have written that, come to here. The last two you write as REV. RE means reverse. After you have written REV, write L to R here in between two same. Again I'll repeat, write last two as REV, and here you write L to R, and in between two same. Okay, now this is the filling part. Start from the first: 3 2 1 0, right? L to R means what? The leftmost bit you have to transfer it to the rightmost bit. So it will become 0 3 2 1, 0 3 2 1, right here 0 3 2 1. After I have written that, same means just write same. What you have to write same? C. C denotes 2 3 7 6, write 2 3 7 6. After that also it's same, which is same F. F is this one 0473, right here 0473. Then L to R for E. E means L to R means 1 will come here, 1 2 6 5, right here 1 2 6 5. After that reverse. Reverse what? B and D. B, if you reverse, instead of taking 7 6 5 4, we will take 4 5 6 7. So right here 4 5 6 7 and reverse D as well. So D will be reverse 0 1 5 4 and that's your code. Okay, that's how you write the color cube code for program 3 and program 4. Coming to the vertices values, we have 1 minus 1s and zeros. So we have to write for both the vertices for program 3 and 4. This for program 3, this for program 4. To fill the vertices values, 8 values you have to fill for both colors and vertices. Okay, and in each of the 8 values you have to write 3 values, either it can be 1 minus 1 or 0. Okay, so start from here. Okay, so colors will be same for both. Okay, so I'll show you how to write colors. Start from the rightmost part. If you start from the rightmost part, write here 4 zeros, 0 0 0 0, then write 4 ones, 1 1 1 1. Okay, then write 0 0 1 1, 0 0 1 1, then write 0 1. Instead of single one, write double 1, then continue double 0, then write double 1 double 0 and so on till you reach the end. Okay, so that's the reverse binary code. 4 zeros 4 ones, double 0 double 1 double 0 double 1, then 0, instead of just a single one, you will write 2 times 1, 2 times 0, again 2 times 1 and a single 0 here. That's the same code here also. Okay, so I'll be copying this code here and then resuming the video. Alright, we are ready with the colors code. Now we have to write the vertices code. So start from here. 0 translates to what? Minus 1. So right here minus 1. 0 translates to minus 1. 0 translates to minus 1. 0 translates to minus 1. 1 is 1. 1 is 1. 1 is 1. 1 is 1. Again 0 translates to minus 1 and minus 1. Minus 1 minus 1. 1 1. Minus 1 minus 1. 1 1. Okay. And here we have 0. So minus 1. And here 1. 1. Minus 1 minus 1. 1 1. And minus 1. So this is the code which you have written for the vertices. You have got for vertices, you are just left with this one. Now here just one change you have to make. What is that change? Here you will write minus 4, here plus 3. The second part is minus. Just remember, second part is minus, first part is plus. So since first part is plus, instead of writing minus 1s here, we will write plus 1s here. So 4 times 1 we will write. After that 4 minus 1 we will write. Okay. For third, plus comes first. For fourth, minus comes first. After you have written this one, just observe here, these two lines are swapped. Swap these two lines and write here. Swap these two lines and write here. If you swap these two lines, this will come in this part. So I'll just copy paste. Minus 1, 1, 1, minus 1, minus 1, 1, 1, minus 1. This line I will write here. Minus 1, minus 1, 1, 1, minus 1, minus 1, 1 1. Okay, this is what you have to write in a different sheet of paper. After you have written this one, you can easily write what program you have and how to fill the values. You can easily type and execute. Also you can write in your answer sheet. Okay, so these two are the code tricks. Okay, so that's all what was there in the trick part and the whole program. Let's quickly wrap up what is in the whole program. Write the header files. After that, global variables, vertices, color, th axis, and plus viewer in the fourth program. The and we have the 6 programs. So vertices and colors you know how to write, and the theta value and the axis and the viewer value, and the polygon and the quad function are same. And this also you remembered how to write this one. And the display functions are here. The theta values are written as same here along with the viewer function, and the mouse functions along with the theta values right here, and then remove that value and write in the spin cube here. In the keys values you write here and keep the mouse function as same. And we have my reshape function, normal functions, and along with that write these two lines of code. We discuss how to write that, and in the main function just the initialization function. Okay, so that's all what is there in the program 1 to 4 tricks, and make sure you like and hit the subscribe button. Thank you so much for watching. I'll see you in the next one.